American Electric Power's Mountaineer plant in New Haven, West Virginia, produces 1,300 megawatts of power every day. Inside the plant, coal is pulverized and burned, generating electricity and sending pollutants up into the atmosphere. But with the help of new technology, the plant is experimenting with ways to clean its emissions. In 2009, it unveiled its Carbon Capture and Sequestration, or CCS, system. Gary Spitznagel is AEP's Director of New Technology Development.
So about 2/3 or 66% of AEP's fleet is coal-based. And when we're looking at the potential for climate legislation that would require carbon reductions, we're so invested into coal that it's very important that we find a technology that makes coal viable in a carbon-constrained world. So we looked at a lot of technologies and decided that we wanted to help the development community come up with something that would work at these kind of power plants.
The system AEP is testing uses chilled ammonia to remove carbon dioxide from flue gas. First, the flue gas is piped into the CCS system and chilled, so it comes closer to the optimal temperature for the chemical reaction. Then, the gas enters a tower and mixes with ammonium carbonate. The ammonium carbonate absorbs the carbon dioxide out of the flue gas and forms ammonium bicarbonate. So at this point, the carbon dioxide has been removed from the flue gas, but the technology still has to remove it from the new compound it has formed.
This is the Regenerator. This is where we take that ammonium bicarbonate solution, we heat it up, and in that process of heating it, it causes the chemical reaction that happened in the absorber to go in the opposite direction. So you turn ammonium bicarbonate back into ammonium carbonate by heating it up. And out of the top of this column then comes a pure stream of CO2. And then out of the bottom of this column is the original reagent that we use to absorb CO2 is reformed, and it goes back to that column to run the reaction again.
Once they've isolated the carbon dioxide, it's pumped to another area of the plant. Here's how they sequester it underground in an animation provided by AEP.
The CO2 is compressed into a liquid-like state and injected under pressure into carefully chosen geologic formations. There, it is permanently stored in rock formations thousands of feet below water tables and drinking water supplies. The targeted storage formations consist of permeable or porous rock, where the injected CO2 spreads through the pores in the rock much like water fills a sponge. The CO2 is effectively trapped from moving upward by layers of very thick and impermeable caprock that lies above the porous formations, much in the same way oil and gas deposits have been trapped for millions of years.
The CCS system at Mountaineer still isn't anywhere near full scale. Right now, it removes about 1.5% of the carbon dioxide from the plant's emissions, but Spitznagel says the company plans to build a commercial-scale system in the future that will remove more of the carbon dioxide. There are different methods of capturing carbon other than the chilled ammonia process the Mountaineer plant is using. But the process is still so energy-intensive, some argue it negates the environmental benefits of capturing the carbon in the first place. Rory McAmoyle is the Energy Program Manager at Downstream Strategies, an environmental consulting firm.
When you add CCS onto a conventional coal plant with chilled ammonia technology, then you're basically losing 20 to 30% of your plant's capacity, meaning that you have to use 20 to 30% more electricity just to capture the CO2 from the stack.
And using more electricity to capture carbon dioxide means that the other environmental impacts of coal increase exponentially.
Which means you're mining 30% more coal, processing 30% more coal, and you still have the emissions of sulfur dioxide and nitrogen oxide, even if you're capturing the CO2. Using Appalachia as an example, when they mine the coal, you have all the related environmental problems to water, to the health of the workers, and to the land. If you put CCS on every plant, you're now increasing those impacts per kilowatt hour by 30%.
Which is why some scientists are looking to solutions other than CCS. Richard Turton is a professor of chemical engineering at West Virginia University. His work centers on modeling a different type of power plant, an integrated gasification combined cycle, or IGCC. Basically, IGCC technology turns coal into a gas. The gas is then burned cleaner than regular pulverized coal. Plus, the excess heat generated can be cooled to steam and used to generate more electricity.
So the combination of running it through a gas turbine and then recovering the heat in a steam turbine is called a combined cycle. And it's a relatively efficient way of making electricity relative to just burning coal, if you like.
IGCC is a little bit cleaner than regular pulverized coal plants because it's more efficient, so there are fewer emissions per megawatt of energy produced. But it still emits carbon dioxide into the atmosphere. Carbon capture can be used on IGCC plants too, but the problem with IGCC is that it requires a huge capital investment. Turton says it makes more sense in the long run than a regular coal plant, but that doesn't always matter to investors.
It's like me telling you, you ask me what recommendation you should buy a car, and I say, well, the best car in the long run that you can buy is a Mercedes-Benz. It's going to cost you, for example, it's going to cost you $85,000. But in the long run, that will be the best for you. And you say, that's great, but I don't have $85,000, so I'm going to buy a Ford or a Toyota, a lower end car. So those arguments are fine, but when it comes down to the person who's going to provide the capital investment, that's a much more difficult sale. Even though in the long run it may make sense, you've still got to come up with that initial amount of money.
Rory McAmoyle says from an environmental perspective, IGCC is a better technology than carbon capture and sequestration. But he says because current CCS technology is both expensive and energy intensive, it could have the added detriment of contributing to the further decline of Appalachian coal. Appalachian coal is already more expensive than coal from Wyoming's Powder River Basin.
Putting CCS on power plants in this region would make our coal less competitive with Powder River Basin coal. Because if you are already paying hundreds of millions to billions of dollars to install a technology that's going to allow you to keep burning coal, you can't also then burn the highest priced coal, because that utility would compete itself out of the market, especially with the rise in natural gas right now.
Advocates of CCS and IGCC say these technologies aren't the final solution, but they're a way to begin transitioning away from coal.
In 600 years, we're not going to be using coal, obviously. We're going to either be using nuclear fusion, or we're going to come up with a bio-based technology that will be renewable, that will sort all these problems out. Of that, I'm convinced. In the medium term, the next 30 years, there's no technology that I see coming along that is going to supplant coal in terms of power generation in this country.
Meanwhile, Spitznagel with AEP says using CCS will allow the company to continue operating its existing coal-fired power plants, like Mountaineer, for the next few decades, or until a better energy alternative comes along. For West Virginia Public Broadcasting, I'm Erica Peterson in Charleston.